So today, as part of our understanding of how trends in the periodic table work, or how the periodic table tells us about how materials are going to behave, we're going to compare three metals: lithium, sodium, potassium. And we're going to see how they react in a similar way, but also in a different way when we place them in water. So, safety glasses on, let's get started. So what I have is a sample of each metal, and right now they're stored under oil to keep the moisture away. We're going to focus on each one of the metals on its own. So the piece of lithium that I have, the larger piece, looks like this. And you can see that it's gone a little bit dull, but it did start out as being shiny gray. I don't know if you can see the freshly cut end there, how well that's showing up, but it's nice and shiny when it's freshly cut. What I'm going to do is take this piece that I pre-cut, and I'm just going to cut it again before we use it, and I can cut it with a knife. So it's a metal, but it's not a very hard metal, it's quite soft. My piece of sodium also has been a fairly freshly cut piece, and again, I don't know how well you can see it, but the piece of sodium, when it's freshly cut, is quite shiny. I'm going to cut that again, and that will be the piece I put into water, and I can cut that with a knife without much difficulty at all. It's a very soft metal. It's softer than the lithium. And then finally, my piece of potassium. Now the piece of potassium I'm starting with is quite a bit larger, but if I take that piece, now this has not been freshly cut, so I'll make a freshly cut piece, and that very easily to cut, and there, how well you can see it, I don't know, but it's quite a shiny bit. We'll get a piece that we can use for our demonstration. So the purpose of this was to compare how these metals behave when we put them into water. So I'm going to start by putting lithium into water. When you put lithium into water, the piece sits on top of the water, but it also produces a lot of bubbles, and it ends up buzzing around on the top of the surface, on the surface of the water, on top of the surface, buzzes around on the surface of the water, riding on that cushion of bubbles. So that's lithium. Doing the same thing as sodium, taking our little piece of metal and putting that into the water. Taking our piece of sodium and putting that into the water. Much like lithium, the piece of sodium scooted around on the top of the water, on the surface of it, riding on a cushion of bubbles. It also gave off a gas. You could see some, it's not smoke, fumes is probably the best way to put it. A bit of an aerosol vapor coming off of the water. It was a more vigorous reaction than it was before. It happened more quickly. If you could hear the sizzling sound, it was a little bit louder and a little bit more, let's say even more quick note to it. Okay, we're going to move on to the potassium, and that's going to be our last one. So then our final move is to put potassium into water, and I cut a piece here. It's maybe a little bit larger than I want, but we'll put that into the water. And I don't know how well you could see that, but it immediately burst into flame. It was a larger piece than I used for either the lithium or the sodium, but it also reacted and, let's say, got used up much more quickly. It also stayed on the surface of the water on this cushion of bubbles. But the other thing about those bubbles is they instead of this time just producing vapors, they actually burst into flame. So we're going to take that information, we're going to take those results, and we're going to compare these metals for how they were similar, but also how they were different. But not only that in terms of what was similar or different about them, but also why. What exactly was going on with the atoms that made them similar, but what was going on with the atoms that made them different?